All right, hello there. We have the CL1 and Watsonx.ai tutorial here today. Today, I'm going to be walking you through how to take a live iPSC culture from Cortical Cloud, which is, you could see the spike readouts here. And basically, I'm going to be showing actually the kind of foundation of how you use something like Watsonx AI to improve your workflows and make using something like whether it is a real CL1 or it is a synthetic data product like BioLLM is just about to be offering in the BioLLM Studio product, how you could be the most successful with whatever approach you want to take. So if we jump right in here, I'm going to just kind of bring you over here to the demo in the Jupyter Notebook. The culture, the 3D here is just kind of for visual support. But basically, if we jump right in, you could see the whole pipeline beginning to happen right here. And, more or less in the first cell, what we're doing is we're adding the HTTP library. So it's available in the Jupyter kernel. And then after that cell runs, these have all purposefully run beforehand because I can't expose my API key, just for security purposes. Um, but we're going to just kind of go down through here, and I will show you more or less, how you would use it. If you put your Watsonx API key from IBM Cloud in here, getting these three items is actually pretty easy, and you can just kind of refer to the IBM documentation for that, and also the structure that you see here, because I am going to just be deleting this project ID afterwards, so not a huge issue. But um, in the configuration, we're saying, hey, we want to record, which we went into in, I believe, one of the previous demos that I did, how long you want to record, how many ticks per second, and the number of channels that you want to record. Why this is extremely kind of important to set this up is because what we're doing in the next area, so we're doing 5 seconds, 1,000 ticks per second, so 5,000 ticks total. And the 1024 is, I believe, we are recording all of the channels. I'd have to double check on that variable, but you could see we get set up right in there. And then when we come down and we record, we import the CL package, which if you're not familiar, go just check out the first 3 tutorial videos I did. This one is kind of getting interjected before we resume the remainder of the documentation tutorial. But when you import CL, import NumPy as NP, and then we're doing a capture here, which we went over, I believe, in one of the tutorials. And basically we're taking the spike count, the total number of spikes, and using with CL open as neurons for taking neurons loop. We are recording, how many total spikes, so we're basically making it so that we can assign down here these different features and then print them out, the extracted features below, so, in this section right here, we have to look at, we have a firing rate of 8.8 hertz, so, that's important here. We have 6 channels that were active when this ran, so it's like you could see 1, 2, 3, 4, 5, 6, roughly those channels you could see on the actual culture itself. The busiest channel, number 51, and it's kind of funny what the AI ends up calling it later, but basically you can see kind of what's going on here. Mean count, the mean count active, and then the number of channels that are showing, I believe, any activity right here. So the max channel count is the maximum amount of channels total that I believe are showing some sort of some activity at all, or have in the last however many minutes. Good, but I would have to check on that one. But for now, we'll just keep, we've got the extracted features from the real culture using the import CL package, CL open as neurons, and then we jump down here and we're grabbing these active channels, and we're reading out that data. So busiest channel, max channel count, and we're looking at spikes, so the total number of spikes happening across those 6. And this is where it gets really cool. So we're coming down here, taking our, in import request, that's why we needed the request package up here. we're importing and getting our IAM token, which is your IBM bearer token. Basically, this little snippet of code allows you to authenticate with IBM, and then we afterwards are able to perform some quick diagnostics. We are calling the Watsonx text generation endpoint with the 8 billion parameter Granite model. I believe we're not even specifying the model yet, but we will be using an 8 billion parameter, as you can see down here, Granite 3. And we're getting the models available. We're just querying IBM here using requests, HTTP request, and getting a response back. So a 200 code. There are 24 models that you can choose from here, and we have the 8 billion parameter model, the Granite models. We're going to be using Granite instruct, it returns to us kind of all of that information. Again, this is kind of just a snippet of code that can help you. I will go and say, like, hey, there is useful stuff here. It's worth paying attention to this piece of code. It's worth paying attention to, how you can authenticate and get what you really want out of this. You can find the model IDs on their website in the documentation as well. But for this area, I would say largely refer to documentation so that you're getting exactly what you want. In this case, we're using this 8 billion parameter 8B model, Granite 3 instruct. And really where we get into the meat and potatoes of this, aside from this code snippet, which, you can pause the video, feel free to pause the video and just grab this. And, there are some, we do perform a minimal generation call right here. So printing the raw response, so any error is visible. But you do, you can see the print down here. But the meat and potatoes of this whole approach is going to be down here in this next cell where it becomes very, very clear our approach. So we're importing JSON. The model ID that we're using is obviously one of the ones that we fetched up here in this list, and we are defining right here that we want to interpret with Watsonx the features, and then we're going to use our IAM token to authenticate with the model of our choice. So those features right here, extracted features, are going to basically end up here, so we prompt Watsonx, this model, we're prompting, so it reads in, and it is being told it's being told that it's a neuroscience assistant, and then we are using JSON to dump those features into the prompt, on the fly, and then afterwards we're forming a payload here, which is the model ID, our Watsonx, so we're able to authenticate. And then the decoding method, which is, in terms of machine learning, greedy, we're using that, so there is, definitely, we're using that, the greedy method. We're using 400 max tokens, so we get a longer complete interpretation. And then the minimum number of tokens in a response is 120. And then we are adding a repetition penalty here as well. I would say refer to, again, to the documentation for Watsonx to ensure that your parameters are going to be kind of bespoke to your solution and able to best interpret the data that's coming from the CL1. This is a very, very simple implementation. Obviously, you can get far more complex, as we will in future videos. Now, the response is we're sending a request, again, using the request library and posting to, Watsonx for a text generation right here. And again, we are putting in that payload via JSON here, and then returning down here the generated text. So you can see response.json returns the generated text here, and then there is the if not, just in case, so we get the response status code and the text that does come back, assuming an error. And down here we are finally getting to the super fun part. This is I would call this a very, very proto version of kind of what we use at BioLLM, and I want to be very, very clear and upfront about this. This is, we're just sending data straight from the CL1 up to, this 8B model. We're not training anything. We're not doing anything like that. But we're getting a response, a contextual response about what's happening on a live culture. And this type of thing, just to give some context here as to how this could be useful. Okay, well, like, great, who is this useful for? This is useful for anyone that is performing research using the CL1 device and, needs the power that, you aren't limited to just, IBM Granite models here. You can use, bring your own model. You can use a plethora of frontier models and be able to, better query those systems, utilizing the Watsonx.ai system. And there's also a number of other wonderful things such as cloud object storage and Watson X data that we are actually going to go into in future videos. So we can show you kind of how to supercharge your workflow, how to build out applications for, wearable compute. This is also a very useful system for, any type of engineer out there that is, working with, kind of frontier AI hardware or software. It's just very, very neat to be on the cutting edge of this and, have data, real spike readout data from real neurons that allows you to, learn about the culture, but contextually on the fly, get updates on it. So you could be potentially make, an agent, let's say you were doing research on neurotoxicity for a certain type of drug over here, you'd be able to set up maybe a Telegram bot or an agent that could text you the status of your culture or your round of stimulations. Obviously, I will perform a small stimulation, kind of has nothing to do with this, but you could see a stimulation happening right there. That is where I send electricity back into the culture. And, having this information from a cutting edge model like Watsonx Granite kind of just allows us to get a foothold on how we can do the best research. You can see the busiest channel, channel 51, which I believe later calls Area 51. It was kind of funny. We see the number of spikes. We see out of the 6 total active channels, half the channels around 7.3 were consistently involved in generating these spikes. Remaining silent channels, it's identifying, the firing rate, 8.8 hertz. All of this different stuff is coming into the response in a contextual and very, nuanced manner that's super beneficial to kind of any type of application that you might want to build outside of this. And I can say, strongly before you jump into, full agentic action, plugging up, Codex or Claude Code straight to your CL1, you really want to get in and understand, right down to, those tutorials that we did before, understand the dynamics of what's really going on each channel and how you're stimulating and, what you can do to make those rounds of stimulation more effective and achieve more of what you want. Whether that is, hey, you're a neuromorphic hardware researcher at IBM, working on the next generation of in silico neuromorphic chips, or if you're building, just a fun application with the CL1 that involves maybe controlling a game better. I know that there was the Doom on CL1 neurons, and then also the Pong game that were very influential in kind of getting that platform out into the public eye. And you have to realize is to make, the gameplay better, you have to use data. There are, actually, I will tell you from my experience, you have a wonderful culture here. But if you don't have the correct data, if your data isn't clean and you're not stimulating in correct cadences, or if you're overstimulating and causing, phenomena such as excitotoxicity, you're gonna have a bad time, and it will play the game, but it won't play it as well as you would probably like it to. So that's super important for any researcher kind of undertaking this, is to just be like, hey, how can I use this AI revolution, which didn't exist when, the first Pong demo was out. It probably was not feasible to use AI as like an LLM to enhance your workflow over there. You were writing the code by hand. I would imagine the Cortical Labs research team is probably writing that code carefully by hand. So, again, to kind of wrap up and get down off my soapbox, we're looking at a full loop here. Neural activity, extracting the features, sending the features to Watsonx.ai, and then returning this interpretation. It's all super, super important, and you're also going to want to, kind of look down at these ideas, which we'll be covering in future videos. But CL06 stimulation, Because that's kind of, a fun one where we will go and again be performing stimulations back to the culture and be able to kind of read things out with a better context and, using, the supercharged knowledge of an AI model like IBM Granite to ensure that, we are being our own best advocate when we're using the CL1 system. So again, my name is Garrett. My email will be in the description, info@biollm.com, and I'd be glad to help you get onboarded with IBM technologies or, with the Cortical Cloud or synthetic data if you are kind of, just looking to experiment and validate a concept. So thank you very much and look forward to having you as part of our journey to come.